If you got on our fastest spaceship right now and headed for the nearest star, you would die of old age 900 times. It takes 70,000 years to get there. But in 1994, a Mexican physicist found a cheat code in Einstein's math, a loophole that allows us to cross the galaxy in 2 weeks without breaking the speed of light. This isn't sci-fi. NASA is actively studying the math right now. But there is a catch. To build this engine, we have to break the laws of physics in a way that creates a doomsday weapon. By accident. I'll show you why arriving at your destination might actually destroy it in a few minutes. But first, how do you move faster than light without moving? Imagine a surfer. The surfer isn't moving fast. The water is pushing them. The Alcubierre Drive does the same thing. It doesn't move the ship through space. It moves space around the ship. By contracting space in front of you and expanding it behind you, you create a wave. The ship sits inside a flat bubble in the middle. You feel zero G-force. You don't spill your coffee. But outside the bubble, the universe is moving past you at 10 times the speed of light. So, the math works. Einstein is happy. But the engineers are terrified. Because to bend space this much, we need a specific type of fuel. And this fuel isn't just rare. According to classical physics, it shouldn't exist. We need something called negative energy. And finding it creates a paradox that breaks the universe. Gravity pulls things together. Mass is positive. But to expand space behind the ship, we need anti-gravity. We need negative mass. We need a substance that weighs less than nothing. Sounds impossible. We've actually made it. It's called the Casimir effect. By pushing 2 metal plates nearly touching, we can create a tiny pocket of negative vacuum energy. The problem, to power a warp drive, we don't need a tiny pocket. Original calculations said we needed a ball of negative mass the size of Jupiter. We've since optimized the math down to the size of a van. That's achievable. So, we build the engine, we find the fuel, we launch. Success? No. Because nobody thought about what happens when you hit the brakes. As you travel, that blue wave in front of you is sweeping up every stray photon, space dust, and radiation particle. It traps them in a high-energy shell. They can't escape. When you arrive at Alpha Centauri and turn off the engine, the bubble pops. And all that trapped energy, it releases in a single instant, a focused gamma-ray burst directed straight at your destination. You didn't explore the planet, you sterilized it. This is the Alcubierre paradox. Any ship powerful enough to reach a new world is powerful enough to destroy it, just by saying hello. But let's say we fix the fuel, we fix the explosion. There is one law we can't fix. If you travel faster than light, relativity says you are also traveling back in time. You could arrive before you left. Does FTL travel break causality? I explored the nightmare of the time travel paradox in this video right here. Click it, and I'll see you in the past.